Let's now look at resistors in series. In the booklet I gave in class, this is on the next page now, on page 74. That was 73 before. Resistors in series. Let's start off with a series circuit. As the name suggests, let's draw a battery. And we'll draw two resistors in series. This is our starting point. Suppose resistor 1 has resistance R1, resistor 2 has resistance R2. Now, it's often useful to find what's known as the equivalent resistance in a series circuit. Equivalent resistance means, rather than having two resistances, R1 and R2, it's possible to think of these two resistors as one big super resistor. Okay, where all you have to do simply is just add the two resistances, R1 and R2. So R subtotal is just R1 plus R2. I'll show you how to derive it quite simply. Now, so in a series circuit, current is the same throughout because there's one big loop. And same thing for resistance. Apologies. Current is the same. We can use this relation. So the total voltage in the series circuit is given by the voltage of the first resistor plus the voltage of the second resistor. That's how you find the total voltage in a series circuit. So suppose the total voltage is 12 volts. How do you find the contributions from each resistor? You simply divide 12 by 2. So it's 6 volts per resistor. Now to go from V to R, you have to divide by I, this entire expression, because it's an equation with an equal sign. Whatever you do to one side, you have to do to the other. So divided by I. So on the left-hand side, you get total voltage divided by current. That is the total resistance. That's equal to resistance 1 plus resistance 2. Okay, because VR1 over I is just R1, and VR2 over I is R2. Now, in general, if you had N resistors, this expression becomes the following. Total resistance is R1 plus R2 plus all the way to R sub N. R sub N, the index N could be anything. Could be 100, could be 1,000 for complex circuits. But in general, that's the case. So that's for a series circuit. Let's look at resistors in parallel. Let's draw a parallel circuit. Once again, we'll use two resistors. Let's suppose that the first resistor has resistance R1 and the second resistor has resistance R2. This is the first loop and this is the second loop. Now, as mentioned before, in a parallel circuit, the voltage is the same in each resistor, in this case. Energy is being equally shared amongst all components. So you can really think of this as being two circuits combined. You've got the circuit from loop 1 and the circuit from loop 2. So if the voltage is the same, so the voltage of the battery will be equal to the voltage of resistor 1, which will be in turn equal to the voltage of resistor 2. In parallel circuits, the current isn't the same. So therefore, the total current is the sum of the currents in the first and second resistor, R1 plus R2. Using these two relations, we can then derive an expression for the total resistance in a parallel circuit. So the total voltage, which is the voltage of the battery, in other words, is VR1 plus VR2 reason why I did plus here is because you can think of these circuits as being two separate circuits, right? So you're adding up the contributions. Voltage of the battery is equal to the voltage of the first resistor, and the voltage of the battery is also equal to the voltage of the second resistor. And I'm just adding them on now. So let's divide by the current, total current, and over here the current in the first resistor, I sub 1, I should say, divide by the resistance, the total resistance. I'll show you why in a sec. And divide the voltage of the first resistor by R1 and the voltage of the second resistor by R2. Now you'll notice here, if you really pay attention, V total, V sub VR1 and VR2, these are all the same. So you can cancel these out in the equation. And what are you left with? You're left with this. 1 over R total is 1 over R1 plus 1 over R2. So cancelling out all those expressions, you're left with 1 on the numerator on each of the terms, and you're left with this. Now, in general, the total resistance in a parallel circuit for n resistors is given by this all the way up to R sub n. Okay, n is an index, could be anything, any integer. Also a note here, this is not how you find the total resistance. You need to take the reciprocal. If you have, let's say, R1 equal to 10 and R2 equal to 10, 1 over 10 plus 1 over 10, find that addition, and then you reciprocate the fraction, and that's the total resistance. You have to be very careful. This is 1 over R total. To find R total, you have to invert the fraction that you get. So that's resistance in series and parallel circuits. Let's do some examples. Okay, so example, let's call it 13.10. This is on the next page of the booklet, on page 75. So we're given a series circuit as follows, so I'm going to write down, so let's tackle this. The first bit, so we're given a battery with voltage 6 volts and 2 resistors. First resistor has resistance 8 ohms, and the second resistor has resistance 4 ohms. We need to calculate the total resistance of the load, in other words, of the 2 resistors. So let's do it. So the first bit, what are we given? We're given voltage, which is 6 volts. So voltage of the battery, 6 volts, and we're given the resistance for the first resistor, 8 ohms, and the resistance for the second resistor, 4 ohms. So this is what we need to work with. Number 2, what do we need? We need to use the expression for the resistance for a series circuit, which is R total, R1 plus R2. And step 3, quite simply, is just a substituting your numbers. R total is therefore 8 ohms plus 4 ohms, and that gives you 12 ohms. That's your total resistance. The second bit of the question asks you to calculate the current throughout the circuit. Now, the current is the same throughout the whole circuit. So whatever value you get, that's the same for either resistor. So the second bit, to find the current, so we need V equals IR, where I is the total voltage divided by the total resistance. Total because current is the same everywhere. Total voltage, that's 6 volts from the battery, and the total resistance, that's 12 ohms, as we calculated in part 1. 6 over 12, that's half an amp. Make sure to put units. Third part of the question asks us to calculate the potential difference across each resistor. So to find the potential difference, the voltage in other words, in the first resistor, V sub 1, we're going to use Ohm's law. V equals IR, where R is the resistance of the first resistor. Quite simply, we're using the total current, so that's half an amp, because current is the same throughout the whole circuit. Half times the resistance for the first resistor is 8 ohms. So we have half times 8, that's 4 volts. Now to work out the resistance for the second resistor, let's use this expression here. Voltage of the battery, voltage of the first resistor, voltage plus the voltage of the second resistor. We know what the voltage of the battery is, that's 6 volts. 6 is equal to VR1, we calculated that. That's 6 volts. 4 volts, I should say. And VR2 is what we need to calculate. So using algebra, VR2 is therefore 2 volts. So these are the resistances of the voltages of the two resistors, respectively. Let's now do example 1311. Okay, this is a series circuit. So we're given a battery 9 volts, resistor 1 9 ohms, resistor 2 18 ohms. So the total equivalent resistance for the two resistors is what we need to calculate. So what are we given in the first bit? Voltage of the battery is 9 volts. Resistance 1 is 9 ohms and resistance 2 is 18 ohms. We need to work out the total resistance. That's 1 over R total is equal to 1 over R1 plus 1 over R2. And you simply plug in your numbers that you're given. 1 over R1, that's 1 over 9 plus 1 over 18. That's 3 over 18. The reciprocal, you need to take the reciprocal of 3 over 18. So that's with a minus 1 on top. Minus 1 in maths means reciprocal. You flip the fraction. 18 over 3, and that's 6 ohms. That's your equivalent resistance. That's one. Number two, we need to work out the current through the battery. Now, using Ohm's law, I is equal to V over battery, V sub battery I should say, over the total resistance. Okay, total. That's 9 volts from the battery. Total resistance is 6 ohms, 9 over 6, that's 1.5 amps. That's the current through the battery. And in the third bit, we need to calculate the current through each resistor. Now, in a parallel circuit, you should already know that current is different in different branches. So the current in the first resistor, I sub 1, is voltage of the battery over the resistance of the first resistor. Voltage of the battery is 9 volts. Resistor 1 has 9 ohms of resistance, 9 over 9, that's 1 amp. We can now use this expression. The total current is the current from the first resistor and the current from the second resistor. Now the total current, we calculated that. That's 1.5. Okay, that comes from the battery. 1.5 amps. I1 is 1 amp plus I2. We need to work out I2. This is the unknown. Using algebra, 1.5 minus 1, that's half an amp. So they're examples, they're typical examples. I'll let you now do page 76, which has got questions.